This is the Ag Engineering Podcast that rolls right into the details on tools, tips, and techniques that improve you, your farm, and our world. I'm your host, Andy Chamberlain from the University of Vermont Extension, and this podcast is sponsored by Northeast SARE. Thanks for listening. Today's episode comes to you from Monkton, Vermont, where we visit with Stephen Park of Full Belly Farm. He and his wife, Sarah, established their farm in 2017 and have about 110 acres. They grow strawberries, blueberries, and vegetables and gross about $400,000 in sales, both in on-farm retail and wholesale markets. They're farming in the climate zone 5A. In this episode, Stephen shares his setup in one of his propagation greenhouses where he's got a rolling bench system with bottom watering irrigation. Now let's jump into the show.
Yeah, I'm Stephen Park, Full Belly Farm. And we're in our new propagation greenhouse that we built this past spring. We decided to go with this style of bench, which is a bottom watering ebb and flow bench, and they're also a rolling bench. With the rolling benches, we saved a quarter of our growing space. We gained a quarter or more of a growing space out of this greenhouse by eliminating all the rows between benches. So that was a huge benefit. We have enough room for a single path down both sides, and we can just roll them back and forth. And even when they're full of plants and full of water and everything, they're easy to move. I do have a little more time. Like I was saying, I was just getting this set up as we were filling them this spring, and I do need to spend a little bit more time on some of the leveling and squaring up and stuff just before next spring. Mostly the leveling, because it's really important for these to be extremely level, because they get filled with water, and so if they're off even a little bit, you have high
one corner will be dry.
Yeah. So this system, we went with the bottom watering system as labor saving. And for labor saving reasons, but it's also a lot of other benefits. Leaves never get wet. We're not doing overhead watering. So as far as disease control, it's hugely beneficial for that. You can also fertilize through this system if you wanted to have fertilizer in your reservoir tanks. We haven't done that so far. We have two different reservoir tanks that we use because we grow a lot of vegetable starts and flower starts, and the flowers, we need to adjust the pH of the water more. We bring it down because we have pretty high pH water here, so we're using citric acid to bring the pH down. And so we use two different reservoirs that we can switch between. So when we're watering our flowers, we're using a pH adjusted water, and watering the vegetable starts, we're using just regular water. We might switch to kind of getting the pH sort of in between so we don't have to manage two different reservoirs. Yeah. We'll see. We're still kind of working with that. And the way this works is we have reservoirs that we fill with water. You can adjust the pH, or you could add fertilizer to that, or you could use biofungicides, and that you can use your root shield and stuff like that. You could add into that water if you wanted, or oxidate if you're trying to sanitize. And then it's all control. We have a controller and a 1-horse pump that pumps from the reservoirs out to the benches. These are set up. Every 2 benches is its own zone. So we have 28 benches, and it's 14 zones. And so you can water one zone at a time. And then also each bench has a valve at the far end. So if you only have plants on one of the benches in a zone, you can also just shut that bench off. Mm-hmm. So you can water 1 or 2 benches at a time. And then you can set a series. So if we come in, kind of a typical day of checking moisture and determining what needs watering, come in the morning, go through, inspect, this zone needs this amount, this zone. And then you can go to the controller and you can set each one of those zones, and then it'll water in a series. And as far as the control on how much water comes in here and how much water they get is really just a matter of how long the pump runs, because so if we have like 128 flats, we tend to run the pump just a little bit less time because you don't really need the level to come up too high over them. You don't want to come over top of them. And larger pots, like if we have larger planters or any of the larger pots, they take a little longer to wick the water up. So we'll run the benches for we'll run the water in them a little longer so that they can have more time to wick water. And then the water comes in at the far end, it fills these benches and it runs for say 12 or 15 minutes, however much water we want to run in them. And it tends to be about 12 to 15 minutes per zone is what we do. And then when the pump shuts off, there's a special type of valve that these have to where if the water's coming in, then it won't drain out. But then once that water coming in shuts off, it allows the water to drain out and it creates a siphon, and it siphons the water out of the bench. And if you look at the far end, we have that 3-inch pipe is where the water drains into. So you use a hose that feeds in to the 3-inch pipe. Some of this is kind of disconnected right now because I was doing some maintenance, but you can walk down here and take a look if you want.
Yeah.
Like I said, I do everything myself, and sometimes it's, it gets the job done, but I'm not always maybe it doesn't look the most professional sometimes. So the 3-inch pipe is where the water drains into. This is kind of disconnected because I'm working on some things right now. But this hose here hooks into this valve, and the water siphons out into this 3-inch pipe that is set at a slope all the way around the greenhouse and just a slight slope, and then it all drains back down to a sump. And in the sump, there's a sump pump that then runs it back into the reservoir.
Okay.
Yeah.
Yep.
So when you set the controller and you want the water to come on, every zone has a solenoid valve, all wired individually. And so if I want zone number 10 to run, I can set that at the controller. That solenoid valve will open for 12 minutes. Then it closes, the water drains out and runs back to the sump, and then makes its way back to the reservoir.
Gosh, that's awesome.
Yeah.
The draining out feature is something I wouldn't have necessarily thought of, but I could see where it's really essential.
Yeah, it has. I mean, there's different ways of doing bottom watering, but these valves are real handy for that. It's like
sure.
Because otherwise, what you would have to do, there's other ways of doing it. So you could set when you set that solenoid valve to open, it also kicks on the pump, which is pumping water in. Now you could set it to where, like, if you had another way you could do it is where you set that pump to run for a certain amount of time, but then the pump would kick off, but the solenoid valve would have to stay open long enough to drain the whole system out before it closed. And so they'd have to kind of run more independently of each other, where with this, the valve closes, the pump shuts off, or it doesn't because it's running another bench, but then the water can still drain and it siphons back out. And then, I just have a sump where getting the slope on that 3-inch pipe all the way around this greenhouse, starting at that corner, across the end, and down to that sump was a little, not too challenging, but
it's a long distance for a drop.
It is, yeah. You don't need much, just enough slope.
Yeah, there shouldn't be any solids going through it, right?
No, there's a strainer where it strains out. Now,
yeah.
A little bit of solids do get in, and that's the one problem I have had with this system so far that I still need to perfect, is that any amount of solids getting into that solenoid valve can clog it.
Oh, yeah.
And what happens is when it doesn't clog it per se, what it does is it keeps the diaphragm from closing completely, and so the water doesn't shut off. And if the pump's still running and it goes on to the next zone and that doesn't close completely, then you're still pumping water in when it's not supposed to be. And that's the problem I've had. And so I have put a screen and filter at the reservoir to try to screen out any solids. But I think if I start with totally clean water, which we clean out the reservoirs and everything every couple weeks at least, and kind of sanitize it and clean it really well anyway, and it runs great. But as soon as I start getting, I think it's algae buildup is what it is, and my reservoir tanks, I kind of cheaped out and I didn't buy new tanks. I bought these IBC tanks and I spray painted them black. It's not good enough. I need really like truly light proof tanks. Enough light still gets through that it grows some algae in there. So I'm going to replace these tanks with some actual like fully opaque black tanks that will keep the light out of them completely. And I think that'll solve the problem because it's really the algae. Because I can screen everything else out as it goes back into the tank, but as that algae comes out of the tank and it causes the diaphragms to clog a little bit, then that's where I have the problem. So it's a simple fix. And this is the first year using it, so I'll have it solved before the spring, before we use it again. But yeah,
there's a few critiques to make, but it seems like you got it all up and running.
Yeah,
quite nicely.
Yeah.
Thanks for listening to today's episode. I hope you enjoyed it. If I can ask you or direct you to do one thing, that is to go to the website for this podcast, agengpodcast.com. That's agengpodcast.com. There you'll find the show notes. You'll find links to the farmer who we chatted with today, as well as photos or videos from the call when I visited the farm. If you've got some feedback to share, my contact information's on there, or you can leave me a voicemail, and you can do that right from the link in the description in the mobile app you're listening to this to. So go ahead and do that. Thanks again for listening, and I hope you have a great day.